The 6.5 Summit. We are talking about AI and making it real and putting together the infrastructure and the building blocks to get that payoff for consumers and for businesses. We love AI here at the 6.5. And you know what? We love even more. That's semiconductors. If you want to hear about semiconductors, you are in the right place, everybody. We're talking about chip designs. We're talking about architecture. We're talking from CPUs to GPUs to accelerators, memory networking, and Foundry Services, and pretty much everything in between. Joining me today is Kevin O'Buckley from Intel, a friend of the 6.5. We are going to chat about chiplet-based designs, packaging, heterogeneous integration, and I don't know, whatever Kevin wants to talk about.
I love it. I love it. Pat, thanks. Thrilled to be here.
Yeah, it's great to see you. It's been a long time since we met in the desert of Las Vegas at your at your big event, and you've subsequently had your big tent event to give updates. And you know, a lot of people might have missed the event. I unfortunately wasn't able to be there in person. Kevin, I was there in spirit, though. I just want to let you know.
I never doubted it for a second.
I appreciate that. So, hey, in 4 years, you have put together a process roadmap that's back on track with Intel 18A. And that includes 18A, you know, it's easy to just say 18A process, but inside of that are a lot of innovations. Things like gate all around, and BSP, otherwise known as backside power delivery. Can you talk about the significance of these two technologies and why does it matter to customers, and maybe even talk about what they're saying about it?
Yeah, you bet. I think as I reflect on our career in the semiconductor industry, Pat, if you go back to when you and I were young pups here, semiconductor advancement. It wasn't that long ago. It depends on
all right.
But if you reflect on early in our career, most of advancement in semiconductors was about shrinking things. It was about making things smaller, which reduced capacitance and allowed the devices to move faster and allowed us to pack more in. And I think everyone has a high level understanding that at some point we ran out of gas on a lot of those just make them smaller elements that we could count on. So innovation is now coming in different areas. And the two innovations that you described that we've introduced in our 18A technology, what we call ribbon fed or gate all around technology. The first of those is about changing what a transistor physically looks like. And in my career, we've really only done that one other time in 25 plus years, when we went from a planar transistor, sort of a flat transistor, to the FinFET devices. And that was 10 to 15 years ago, depending upon where you were in the industry. So, going from a gate that sort of wraps around the top of the transistor to now a gate that goes all the way around top and bottom of the transistor is a huge innovation that allows us to make transistors faster without compromising performance. And then our backside power technology addresses the other element of silicon scaling, which is, okay, I got a really cool fast transistor. How do I get electrons in and out of that transistor? And backside power, for the first time anywhere in the industry, allows us to use metal levels on both sides of the transistor, both from above and below, which offers huge advantages in power performance. It's a big deal for us to be first in the industry to combine these two technology elements.
Well, it is, and particularly given where you came from. I've been tracking Intel for 35 years, and a lot more ups than downs on what's happening. So it's been pretty astounding to me that, it's funny, people say 4 years, gosh, that's a long time. I'm like, 4 years, wow, that's not a long time in this industry. I used to work for a company that had a foundry, and then it didn't, given how hard it was and how capital intensive it was. So yeah, and the last 4 years since I've been even meeting with pretty much every executive at the company on the ELT, my first question was, hey, how's 5 nodes in 4 years going? How's this going? And people are like, well, you don't care about the design? I'm like, no, of course I care about the design. And Intel needs really good designs and really good technology to manufacture of that in, and it does seem to be coming together for you. But I want to auger in into AI. I mean, what an opportunity for silicon. Listen, I always thought silicon was cool and sexy and important, but it took a little bit of time for the rest of the other markets, the capital markets, the software markets, right? Software guys are like, hey, it's all about software. Software is eating the world. And my response was, you're not going to run that software on air, okay?
Right.
And now, really, semiconductors are leading the charge in AI. So, pretty broad question. How does your roadmap align with the needs of AI and HPC workloads? And again, you've got to make a bet now for something that might pay off in 4 years, or 4 years ago you would have had made the bet then for it to pay off now.
That's exactly right. I think I'll hit it from two angles, Pat. The first, from the fundamentals of the semiconductor. The good news is from an Intel perspective, the good news is our legacy, our history has been as a semiconductor technology manufacturer focused on high performance computing. We've been developing technologies that, for what had been our only customer for many, many decades, Intel products, to enable high performance compute, which is very, very similar and very well aligned with the needs of AI accelerators and the compute host nodes that connect to them. So whether it's at the advanced nodes, the two technology elements that you and I just chatted about, our 18A technology with backside power and ribbon FET, those are exactly the drivers that the industry needs to enable the highest level of AI compute. The complement to that is, I think we all understand, AI compute, especially in the training space, is not about what's happening in our pocket. It's about what's happening in mega scale data centers that are just extraordinarily interconnected. So for that, you need networking capability, which is core to our offering, everything from copper connectivity to optical connectivity, but just as relevantly, the packaging technologies that allow, instead of a computer being one chip, maybe with a couple sockets on the board or 4 sockets in the most advanced server configurations, to no, dude, this is 100,000 boards all working coherently as a single compute element, which is literally what's happening in our data centers right now. So for us as Intel Foundry, Pat, it's the semiconductor technologies that we talked about, and now the interconnect technologies, the advanced packaging technologies that allow that scale and those massive compute systems to operate coherently. And I'm thrilled that we've got both as core to our Intel Foundry offering.
Yeah, the industry has come so far. I mean, it used to be just a discussion about CPUs, and then CPUs, GPUs, and then once we ran into bottlenecks there, we started talking a lot about HBM, and then we also talked a lot. Packaging used to be a second-class citizen. Now it's as important as the wafer itself, and I'm sure we could debate this, but you're not going to have advanced SoCs without advanced packaging. So it's all
you and I
together.
You and I don't need to debate this one, Pat. We're definitely on the same side of this. My perspective there, and it sounds like it's aligned with yours. Not that long ago, like 5 to 10 years ago, packaging was really about, hey, I've got these little tiny solder bumps on a chip, and I need to connect them to big solder bumps on a board. And that's what packaging was. Right? It was a glorified space transformer to let us connect solder connections. Now it's just the fundamental driver of 3D interconnection, compute density, and it's just such a change. There just in the last couple of weeks was the annual ECTC conference. It's one of the major packaging conferences, and it was like filled with rock stars. I mean, those packaging conferences, as a leading indicator of where the industry is putting its attention and its investments, was just filled with some of the most exciting advancements in the industry.
Yeah. So one of the biggest architectural changes to chips is moving from these monolithic designs into chiplets. I mean, listen, if you can have good yield on that, 800 millimeter wafer, go for it. Okay. But the reality is that that's not the case. And why put something on leading edge node when it doesn't have to, when you can put it together in a chiplet configuration and put the right silicon on the right node, but you can't sacrifice performance and you can't sacrifice power. So we had a good conversation about packaging, but talk about some case studies, some recent successes, right?
Yeah.
Is this working? Are you actually doing this right now?
We are. There's a couple of awesome use cases that I think that are right down the middle of the examples that you used. One of the areas where scaling in semiconductors broke most fundamentally was in memory scaling. So the industry's gotten really effective and creative about continuing to scale what we call logic, the fundamentals of making flip-flops and storage gates and things like that. But the SRAM, the fundamental storage unit, is actually really not scaling well. So an example of use case that we're seeing a lot of, AMD was a great pioneer of driving this, and some of the solutions they're doing. Intel products is as well, and a number of other companies, is disaggregating their compute, the fundamental core compute blocks from a lot of the memory. And I'm not even talking about DRAM and HBM. I'm actually talking SRAM. So there are some incredible advanced packaging applications today where the most expensive, aggressive logic technologies are used to get those fast transistors to do compute. But the memory can be sandwiched right on top, using through silicon vias, so that you can do those SRAMs in a more cost-effective technology without substantial compromise.
Yeah.
And by the way, the advantage is those 800 millimeter monsters that you talked about, I don't need to compromise that with my SRAM. I can do the SRAM up here, and I can use that full 800 square millimeters or less if I want to be more cost effective for the logic devices and the logic devices only. And that's allowing a lot more compute capacity to be deployed more cost effectively. The other big application there, Pat, that I think of is connectivity. It used to be when you did what you and I would call an SoC, you would have, the compute, and then you'd have PCI, you'd have your DRAM interfaces all integrated monolithically into a die. And we can now push a lot of those expensive, esoteric, that is a compliment, analog circuits onto a separate chip. And you can, again, focus your compute investment in the center die and get all of your N-1 technology utilization of, hey, perfectly good enough 64 gig or 128 gig per second PCI PHYs for the latest configuration, or the latest DDR or HBM PHYs you can put on a separate die. Huge leverage in AI in particular.
Yeah, I appreciate you correcting me. You can do it. You can have an 800 square millimeter die, and you can stack stuff on top of it.
It ain't cheap, dude, though. You're right. It ain't cheap. That is extremely expensive implementations.
Yeah, we definitely see that with memory, for sure. So, hey, it does take a village to be successful as a foundry company. I mean, from tool partners to IP partners, right? To really pull it all together, so you can have a potential customer that can come in and have the confidence that their design is supported every step of the way, and it's going to be nothing is easy. Don't get me wrong, but as easy as it can get, so they have a decent time to market. Can you talk about, on the chiplet side, the ecosystems, the collaboration, the partnerships you're pulling together to make this a reality?
Yeah, you got it. This, Pat, maybe, as I reflect on the transformation of Intel Foundry over the last few years, I tend to jump a lot to, hey, look at these new technologies we've developed. We've got these new features. We're driving state of the art. Maybe perhaps the biggest transformation to the company and the business has been in a necessary embrace of an ecosystem of partners, so that we have what our customers need, right? And just speaking openly, that's not historically what many would consider Intel's core strength, right? Intel had hey, this is how we do it. And embracing companies like Synopsys and Cadence and Siemens on even just the EDA tools. So we're using what all of our customers expect to use. And in the chiplet space, embracing IP partners that can put in place standard chip-to-chip connectivity that will work whether we Intel Foundry manufacture the die, but we may be talking to a chiplet manufactured at another foundry. That has to work. Customers cannot have to worry about that interoperability. So having common
Yeah.
partners for IP and standards is really critical. We've announced a chiplet alliance that has so many of the familiar names that you would expect on the IP side and the EDA tool side, but also design services partners. Even packaging partners. So one of the announcements we made at our Foundry event a month or so ago, Pat, for the first time, us as Intel Foundry, we actually brought the Amkor team out on the stage and said, hey, if you want to use our most advanced packaging technology, what we call EMIB, historically, you've only been able to buy that from Intel, but you've told us, customers, that you want an ecosystem of partners to be able to manufacture these advanced packaging technologies. And we're enabling Amkor to do so because that's your voice. And that's a big change for us.
It is. And I have to tell you, people talk about the new Intel. I think your side of the business embodies the new Intel a lot. And, part of it is you have to, because it's other design companies, like, to really fulfill your vision, you need to bring in new design companies in other than Intel's design. And,
right.
And a relationship, like any relationship, is a give and a take, right? You're giving things back to the industry, and the industry is giving you back things as well. And that's just the mature way to look at technology. And listen, you're going to fight like heck, to win as much market share as you can, but finding those smart places to work with others and make it a good bi-directional relationship. You can make money, they can make money, you can, walk off into the sunset. Gosh, I'm about to cry here.
I'm right there with you. Let's go find a beach together, man. I'm all
exactly. Hey, this has been a great conversation. We have time for one more question here. So, how do you see? Listen, it's funny, things that are sometimes come up new on people's radar screen. I'm thinking that's not new, and I kind of ignore it. But this whole idea of heterogeneous integration, right, which is essentially a couple ways to look at this. Heterogeneous can be in design, in the way that you do this. It can be just a distributed architecture. There's a lot of different ways to look at this, but how will this market evolve here? It's funny, on the mobile side, they're all like monolithic designs, baby. Right? Anything that seems to be below a certain threshold is, it's not a heterogeneous design. And I'm just curious, like, not necessarily even on mobile, but just overall, how does this market play out, and what is your role in this?
I think heterogeneous means different things to different people. I love the question. The way I see it, Pat, is I really do think heterogeneous integration is the inevitable endpoint for us as an industry across all markets. Right now, of course, there's an intense focus on AI, but we've already seen heterogeneous integration in general purpose compute, even in PCs. Lower end PCs even are using heterogeneous compute to enable customers to develop products that can address a broad spectrum of applications. I have no doubt that we will see this in the mobile space. I have no doubt that we will see this in the automotive space in a variety of different markets. We can debate the when, but my personal perspective is it's going to happen. The economics will demand it, and the compute demand and the connectivity demand that we're putting on our products will also demand it. So I think it's inevitable. There's one other aspect of heterogeneous that I want to acknowledge. I think that's really important, and it's one I truly think we're standing tall as an Intel team in delivering, and that is, like, my goal is to add value to my customers right now. As big a company as Intel sounds like, I'm a startup in the foundry space. I am a startup, so I have to do things to ensure that I'm adding value to customers. And one of those is heterogeneous. To me, is heterogeneous with a capital H. I'll put an Intel Foundry die next to a piece of TSMC silicon or Samsung silicon. Heck, I'll take other foundry silicon and put them using my EMIB technology to connect them with. And we're doing that today. So heterogeneous for us is about figuring out what the customers want, what the market needs, and enabling. And we are investing to be a premier heterogeneous supplier, because I really think that's where the market's going.
Yeah, I think it is too. I mean, to me, it's a foregone conclusion on certain types of silicons and certain type of market. I'm waiting for that first smartphone chip to pop up and have it. But having them in PCs, I think, is a good first step here. So
Right on.
Kevin, man, this is great. I really appreciate your time here. You know, you have a lot more work to do, but you've achieved a lot. I'm looking forward to seeing Panther Lake. I'm looking forward to seeing Clearwater Forest. I'm excited about those, but to be honest with you, I'm more excited about your Foundry customers and when you start cranking out chips on 18A for them. Even though I know you're doing, you know, on other processes before that, but I'm especially excited about 18A because 18A I believe is really the, you know, I'll call it the grand opening for Intel Foundry. You know, the doors have been open, but you know, with customers walking out with the goods is I'm going to put it on my calendar.
We see it the same way, Pat. We see it the same way. Thank you, man. I always get energy talking to you, man. I really do. I always
Good. I
appreciate
hope
that.
so. The same. I hope you feel the same. I mean, I love this stuff. So, yeah, thanks for coming on, and hopefully we can have you on again in a few months.
Anytime. Always fun, Pat. Take care.
That was a great conversation with Kevin. Hopefully you loved it. I just want to thank you for attending this Semiconductor Spotlight for the summit in its 6th year. We're all talking about AI. And with semiconductors from GPUs and AI accelerators to foundries, chiplet ecosystem, this track is looking at the entire full stack moving forward. You can view the entire agenda at 65summit.com. Stick around. We've got more insights and executives coming up.